Hi everyone, and welcome to the walkthrough video for our periodic table of elements location here in Engage. We'll go ahead and get started by clicking that Start Session button over on the left side of our Engage home menu. Then we'll go up to this tab at the top left. Yours might not say Lobaki, it'll probably say the name of the group or organization that you are working with. But regardless of what it says, this is where all of our custom content and locations will live that you'll be able to access. So we'll go to page 2 here, and we will see the periodic table location. I'll go ahead and click on that using the trigger button under my index finger, then select just me, since I'm the only one in the session right now. And here we go. All right, here we are in front of our periodic table of elements, floating in space. We've got an info screen back here behind us that can give us some directions. We've got a control panel here that can switch between views or toggle a couple other things that I'll show you here in just a moment. We've got our batons that we can use for different ways of teaching and learning. So, for example, anything that I touch or interact with in this scene with my batons will be visible to everybody else in the session. So if I'm playing the teacher and I wanted to walk up to the periodic table and select a specific element, if I selected it using my batons, everybody else in the session would be able to see that I selected that. Versus if I just select something with my hands, only I will be able to see that in the session. Then over here, I'm actually going to go ahead and turn off our background music, but I'll leave on our sound effects. All right, let's take our batons back over to the periodic table here. And I'm going to start by launching out a whole block, a whole group of elements. So I'll just walk straight forward and stick my baton into our transition metals. We know that these are the transition metals too because we've got those labels over on the other side, and we can see that this one is color-coded to match that light yellow. All right, so now we've launched out this whole group of transition metals. And if we look back at our info screen, sure enough, we see we have this graphic that's popped up that says transition metals. It shows us where it is on the periodic table, and it'll tell us some of the facts and figures on the transition metals group. Right now, we don't have any one individual element selected, though. So we can go ahead and do that. We can go back over to our periodic table and use our batons to select, gotta do gold, right? There we go. Now we have gold selected. On the info screen, we can see it says gold. We've got its atomic number, its atomic weight of 197 about. Phase at room temperature is solid. We've got our density, melting point, and boiling point, our electron configuration, and the year discovered. Also over here on the right, we can see a diagram of its electron configuration and the electron levels listed out right here. So for example, that 1 on the end is that same one little electron that we're seeing in that outermost shell right there. We can also see that we have 79 protons and 118 neutrons that together add up to that atomic weight of right around 197. Now, we can actually pick up a chunk of this element by coming over to this vortex and sticking our hand inside. And then we can just pick it up, just like we were with the batons. Just bring your hand up to it and squeeze your trigger under your index finger. And here we've got a lump of gold. Now, if we wanted to have students make observations, maybe they're doing a report on their favorite element or something like that, We can turn on our overhead hood by just hitting that button. And now we've got a blank white background that we could use to maybe take pictures of our element against. So I can bring up my menu and go to the camera over here. That's a little close. I'll back up a bit. There we go. So I can click take picture, and that'll save to my headset. And if I wanted to make observations of any specific element for a report, maybe, that's a great way to do that. We can turn back off that hood. Now let's go over here to the other end. And we've got this table right here that shows us the electron orbital configuration of that specific element. So, looking at gold, for example, we can see we've got all of the energy levels laid out here, and the energy levels are divided up further into the different orbital shells within them. And then each orbital shell is further divided up into the number of electrons that orbital shell can hold. So, level 5 for gold doesn't quite fill up all the way. We haven't hit that 5F block yet. But we do have one electron appearing in this 6S block right here. That one electron right there is that same one that we were looking at right there and right there. And here's where it gets really cool. We can actually walk out over this void and take a look at this gold atom. And there's that one lone electron in the 6S shell right there. We can walk straight on in and look at all of these crazy orbital shells and all of the electrons inside. And if we get really close here in the middle, that magenta sphere right there is actually our tiny little nucleus. Back on out here, and let's look at another element real quick. So, for example, if I selected an element right next to gold, platinum maybe, number 78, we would launch out platinum, and we would see its electron configuration as well as all of its facts and figures. Just like gold, we can pick up a chunk of platinum. That one's pretty cool. And we're noticing something interesting here in our electron configuration. But let's actually use this table to take a closer look. So I'll hit Show Electron Orbitals, and we'll see that it's different from gold in that it didn't fully fill up its 5D block, and it still went ahead and put one of its electrons in the 6S shell before filling up that 5D block. So that's a little oddity that becomes really clear when you're looking at the electron configuration in this way. So we can walk out there and we can still see that we have that one lone electron out there in our 6S shell. And then if you really wanted to count all of the electrons in the 5D shell, you would see that there are in fact only 9 of them out there, but we'll save that for another time. I've got an exit button over there and over here that I can use to close out of this specific element. And that'll just take me back to the group that we were in. If I want to close out of this group, I can just hit this exit button. It'll go back into the table. And then, of course, I can easily launch out any of the other groups just like this, or close them. Let's do something really cool. Let's look at our noble gases. You might be wondering, how on earth will we be able to pick up a chunk of a noble gas? Well, just like this. I'll launch xenon, for example. Then we'll go back over here. And my xenon, it's not a rock, but it is a ball of gas that I can pick up and move around. And this is approximately what xenon might look like if we ran an electrical current through it and tried to use it in a neon light or something cool like that. Now things get really interesting when we start to get higher up into the elements and look at the ones that don't exactly exist in a normal observable form and might have to be created in a lab. So for example, the biggest element, number 118, Organescen. Organescen doesn't exist for more than a few fractions of a second at a time. And so to show that, we just have this animation of some particles colliding as they would to form new elements. And then for a brief fraction of a second, we have some magical new element created. Now, Organescen, of course, is number 118, so it's got all of the possible electrons, at least that we know so far, and all of its orbital shells are filled up. So look at that. Wow. A giant Organescen atom. Now, just like before, we can walk across the pit and go take a look inside of this thing. Look at all this craziness. Or we could get a slightly different view if we hit walk into pit, and that'll launch these steps down below here that I can jump down inside and look up at the Organescen atom above me and all around me. So I can teleport up to these other levels and view it from different heights. And then I can just teleport back on up. Come on. There we go. Back up and out when I'm done. Alrighty. I will close out of Organescen here. And if you ever wanted to get rid of the pit, you can just hit walk across pit, the invisible floor, and you'll be able to walk straight back out into the void. A couple more things that I'll show you here. Let me go ahead and close this. There we go. Over at our control panel, we have a few options here. If we hit expanded table view, that'll actually show us a slightly different view of our periodic table. It puts the lanthanides and actinides up here, kind of next to the transition metals and next to the alkaline earth metals. And this is just another way of viewing the table. It might help make things a little bit clearer with some of the numbers here. As we get into the 60s and 70s in the lanthanides, those continue right on into this row in the transition metals. And similarly with the actinides, up into the hundreds, continuing straight on in to the transition metals. So this functions just like the other mode would. We can launch out specific groups. It's just a slightly different way of viewing it. And I can easily switch back to the traditional table view. I can also launch a specific group using these group label buttons right over here. So alkaline earth metals, for example, click that, and there's that group. If I wanted my students to identify which groups of elements were which, I might want to hide these element labels. And now all of my element labels are blank, And I can show and hide these by just walking up and selecting each element to reveal its label. So let's say I were going on a hunt for aluminum, for example. I might be searching somewhere in this area because maybe I remember it's, part of the post-transition metals or the metalloids, and so maybe I'm searching around. There it is, right there, aluminum. Now I can also show or hide entire groups of elements here. So for example, I'll hide all of our post-transition metals, all of our metalloids, just by hitting that hide column. And I'll hide all of our transition metals as well. So if I wanted to show all of the alkaline earth metals, for example, I can just hit that show column, and there they all are. We could do all the lanthanides, there they all are. And so this is a great tool that you can use for memory activities and identifying which elements are where. And I can just click Show Element Labels again to take us back. And when it looks like we had the lanthanides still selected, so I'll close back out of that. You can also hide the group labels if you wanted students to be able to just identify which groups were what without those labels off to the side. But we'll turn those back on for now. And there we have it. That concludes our tour of the periodic table of elements location here in Engage. I hope you all have a great time using this to teach about chemistry and the elements in your classes. Thank you so much.